Hello students. So in the previous class we were talking about that of the atomic number and mass number and how with the help of the atomic number, mass number we are able to find the number of electron, proton and neutron. So why before understanding the last model of the atom, that is Bohr model of atom, we jump to the atomic number, you will understand when I will explain this Niels-Bohr model that what is the use of this atomic number in the Niels-Bohr model of atom, who has also explained the electronic configuration of the atom. So before we start, student, remember that when we were discussing that of the Rutherford model of atom, he has given some of the postulates in which he explained the main thing, and that is that all that an atom is consisting of a positively charged particle which is heavy, concentrated at the center. Okay, so positively charged particle, heavy and concentrated at the center, that is known as the nucleus. Okay, and around this nucleus are negatively charged particles they used to revolve around it. So Rutherford, he explained that positively charged particle present at the center and negatively charged electron they used to revolve around it. But Rutherford is also having a limitation, that is, he said that electrons they used to revolve around the atom. So since if electron is revolving around that of the atom, so what will happen? It will start continuously losing the energy in the form of an electromagnetic radiation, and finally it start coming close towards that of the nucleus and falls into that of the nucleus. Okay, and we can say that atom finally collapse, but you know that it never happens. Okay, so this limitation has been explained by that of the Niels-Bohr, and on that basis he has given a model of an atom, and that is Bohr's model of atom. So Niels-Bohr model of atom, Niels-Bohr he explained that atom is consisting of a positively charged nucleus. Electrons they used to revolve around it, but they used to revolve around the nucleus in a stable orbit without radiating energy continuously in the form of an electromagnetic radiation. Let me tell you that what he explained first, and then we will discuss about the postulates of the Bohr's atomic model of atom. So he said that the electrons it used to rotate around the nucleus. Okay, so it rotates around the nucleus in a certain stable orbit without losing energy. Losing energy, or in place of that we can write it without radiating energy. Without radiating continuously in the form of electromagnetic radiation. Okay, so electron it used to rotate around the nucleus in a certain orbit. The orbits are stable and they used to radiate in that they used to move, they used to rotate in that orbit, and there they do not radiate any energy in the form of electromagnetic radiation. Okay, so this is the basis of that of the Bohr's model of atom. So Niels Bohr, at first he explained this, that the drawback of the Rutherford model of atom, he explained that why does not it occur, explained by that of the Niels Bohr, and finally on that basis he has also given some postulates that we will explain, that we will study right now. Okay, so he explained that electron, it used to rotate around the nucleus in a certain stable orbit without radiating energy continuously in the form of electromagnetic radiation. Okay, now we will discuss the postulates. Postulates of the Bohr's atomic model. Postulates, students. So the first postulate given by Niels Bohr, that is, the first postulate of the Bohr model of atom is that an atom consisting of a positively positively charged particle at the center, and electrons, which is a negatively charged, revolves around the nucleus. So we can say an atom consisting of a heavy positively charged particle present at the center, and electrons revolves around it. Okay, so he also explained the same thing as Rutherford has explained, that atom consisting of a heavy positively charged particle, which we call as a nucleus. This nucleus is concentrated at the center, it is present at the center of the atom. Okay, why positively charged, student? Because of the presence of the proton and neutron in it. Since neutron is having no charge and proton is having positive charge, so it is because of the proton the nucleus is positively charged. Okay, you know that the sum of the proton and neutron is known as nucleons. Okay, now electrons, they used to revolve around that of the nucleus. Electron is what? Negatively charged particle. The second postulate he explained, the electron which revolves around the nucleus revolves in a stable orbit or having certain selected circular orbit. So it revolves in a certain selected circular orbit. So a fixed orbit is there, student, a circular orbit is there where the electron they used to revolve. Now, what is the speciality of this orbit, student? This orbit is having a energy in it. A fixed energy is present in this orbit, and that is why these orbits are also known as energy shell or energy level. So we can write it. That is, these circular orbits are having fixed energy. Thus, orbits are also known as energy shells or levels. Okay, now see the students, they used to rotate around a circular orbit, and this circular orbit is having a fixed energy, and that is why these orbits are also known as energy shell or energy level. Remember that. Now, how many orbits are there? There are a lot of orbits. Like if suppose we will say that there are 1, 2, 3, 4 circular orbits are there. So there are a lot of orbits are there. So we had given a name to these circular orbits, and that is KLMN. These circular orbit is named as KLMN, like that. Okay, so if the different shells are there, if different orbits are there, so we can say that these orbits are having a name. There are a lot of orbits are present along the nucleus, and we have given a name to it like that of the KLMN. So I'll show you how it is for students. Then we will go further with the next postulate. You see here, if suppose this is a nucleus, okay. So what I want to say that Bose he said that there are lot of a circular orbit around that of the nucleus where the electrons used to revolve. This circular orbit is having the fixed energy, and that is why these circular orbits are also known as the energy shell or energy level. So see here, if this is the first circular orbit, then this is the second circular orbit, then this is the third one, and finally this is the fourth one. Okay, so you see here, these are the different circular orbits, student. Now, these circular orbits, these are the orbits, and all these orbits are having the fixed energy. Okay, and since it is having the fixed energy, we can say that they are fixed energy. They are also known as by a name, that is energy shells or energy level. Now these circular orbit is having the energy shell. Now energy shells, there are not one shell, student. You can see there are 4 shells. So we had given a name to each of the shells, that is K, L, M and N. Okay, so these are the different shells. Now the energy also, it means that if this is the first orbit, if this is the K shell, K energy shell, so this energy is this orbit energy will be different from that of the L orbit. The energy of that of the L energy shell is different from that of the M, and same thing with the N. So they all are having the different energy, or we can say they all are having their own fixed energy. Now the electrons, which is having the minimum energy, it will go to the energy shell which is having the minimum energy, and the minimum energy shell is present near the nucleus. Okay, so we can say that minimum energy of energy level will be near to the nucleus. Okay. So by this, student, we can say that if an electron is having the minimum energy, okay, if I am saying that this having the minimum energy, that is why it is close to that of the nucleus. So we can also say the electron which is having minimum energy goes to the energy shell which is close to the nucleus. And which one is close to the nucleus, student? That is K shell. So you see, students, the electron which is having the minimum energy, it will goes to that of the energy level, it will goes to that of the energy shell which is having the minimum, which is close to that of the nucleus. So this energy level, this energy shell is close to that of the nucleus. So the electron which will have the minimum energy will goes into that of the nucleus. Now as the electrons starts moving from this shell to K and M, it means that as the electron energy increases, it start moving far from that of the nucleus. Okay, so try to understand it again. If an electron is having the minimum energy, it will goes to that of the shell which is near to that of the nucleus, and that is the K shell, right? Now, if the electron is having a more energy, then it will enter into that of the L shell, okay, which is little bit far away from that of the nucleus. Okay. Now, again, if the electron is having more energy, so we will much more energy, then we will say that it may enter into that of the M shell, which is more far, or which is far away from that of the nucleus. Okay. And if it is having the more energy, highest energy, it will enter into that of the N shell, which is very much far away from that of the nucleus. So you can see the electron which is having the minimum energy enters into the shell which is close to the nucleus, and the electron which is having more energy, much more energy, it will enter into the shell which is far away from that of the nucleus. Okay, so you see here the electron which is having the minimum energy goes to the energy shell which is close to the nucleus, that is K shell, because student, K shell is that shell which is the closest to that of the nucleus. It is the first energy shell. So the electron which is having very less energy, very minimum energy, so they will enter into that of the K shell. Now you see here, if we talk about the other electrons, the electrons which is having more energy will start moving to the nucleus. What does that mean? It means that is it will enters into the shell. Shell, it means energy shell. Enters into the energy shell which is far away from the nucleus. Okay, so electron which is having the minimum energy, it will enter into that of the K shell, and the electron which is having the more energy to start moving to that far away from the nucleus, start moving, entering in that circular orbit in that energy shell which is having the which is far away from that of the nucleus. Now we move to the next postulate, students. So next postulate is that the electrons which is present in an orbit, it will neither lose energy nor gain energy, but it will remain constant. Let me tell you before that, student, when we had divided the shell, we said that each shell is having the different energy level, and it is having a fixed energy shell. So the energy, when I am saying the electron which is having the minimum energy enters into the shell which is the nearest to that of the nucleus. So if suppose this is the energy of that of the K1, K, then it will be E2, then here M, it will be E3, and this it will be E4. So they all are having a different energy from each other, but that is a fixed energy which is present in that orbit. Okay, so by that, student, we can say the electron which is revolving around its own orbit, which is in an orbit or in a particular orbit does not change. Revolving in an orbit, it does not lose or gain electron. So you see here, students, that electron which is revolving in a particular orbit, it will neither lose electron nor gain electron, and it is because that all the orbit which is present around the nucleus, their energy level is fixed. So we will write it, the energy of each energy on each orbit fixed. Thus, we call these energy shells as a stationary orbit. So we write it that each energy shells are known as the stationary orbit. I am writing here, students, that is known as the stationary orbit. Okay. So the electron which is revolving in an orbit, it does not lose or gain electron. Why is this so, student? Because if an electron is there and it is continuously revolving around this orbit without losing or gaining energy, it is because that this orbit is having a fixed energy. And since it is having the fixed energy, the electron which is revolving around it will neither gain electron nor it lose electron. So if an electron is revolving around it, it will neither gain electron nor lose electron because of the fixed energy with present in that of the orbit, and that is why this energy orbit is also known as the stationary orbit. Okay, so why it is known as a stationary orbit? Just because of having a fixed energy level, fixed energy in it. Now you see here, students, we are saying that it will not going to lose energy or it will not going to gain energy. But what will happen if suppose you will provide energy from an external source to that of the electron which is revolving in the orbit. Okay, so if an electron is revolving, here, students, okay, so this electron is having a certain energy and this energy will be equals to E1, right? Since it is equals to that of the E1, and that is why it is continuously moving in that particular orbit. Now, when you provide an extra energy to this particular electron which is revolving in the K shell, then what will happen? This E1 will get more energy, that energy will be equals to E. Suppose that this energy will be equals to E, students. Now as this electron, it was having an energy that is equals to E1, you had provided an external energy on it. As you provided external energy on it, students, what happened? This energy may be equals to E, and now it consumes, it absorbs this much amount of more energy. So now its energy get increased and this energy will become E2. Okay? I'll explain you again. See, an electron which is revolving in the K shell is having the energy that is equals to E1. Now an external source is supplying energy to this electron which is revolving in that of the K shell having energy E1. So as it absorbs the energy, its energy get increased to E2. Right? So now this energy from E1 will get increased to E2. Now is it possible for this electron to revolve in this stable orbit, in this orbit? No. Why? Because the energy got increased. Now the energy of this particular electron which is revolving in the E shell, E1, in the K shell which is having the energy E1 is not even right now, it is more than that is E2, and E2 is the energy level of that of the K shell. Okay, so we can say that this electron will, you have provided the energy to its students. Okay, so you have provided an energy and due to which energy got increased, and finally what will happen, the energy will become equal to the next orbit. So it will jump into the another orbit. So this electron will jump into that of the K shell, it will be jump to that of the L shell. Okay, so why is this so, student? It is because it absorbs the energy and that energy is equals to the E2. Okay, and this E2, this energy, fixed energy is of a L shell, so it will jump from one shell to the other shell. So for this student, we can write it. When an external source provides energy to the electron of a particular shell, what will happen? It will absorb energy. So it will absorb energy, and now the energy get increased, students, so you will say, and it will jumps to the next energy shell. Energy shell. Okay, so when an external source it provides energy to the electron of a particular shell, it will absorb that energy, and finally what will happen? It will, after absorbing, energy got increased and it will jump from one shell to the other shell. Okay, now this state of the electron in which it jumps from one shell to the other cell is the excited state. Why excited state, student? Because it absorbs the energy. So before that, when it was moving in its own shell, when it was having its own energy and it was moving in own shell, that state was known as a ground state. When it absorbs the energy and jump into the next shell, that state is known as an excited state. Okay, so we will write it, that is when it was in its own shell, then it was at ground state. But as it absorbs energy, and jumps to the next energy shell. That state is known as excited state. Okay, so this state is known as the excited state. Now, the excited state is not a stable state. Okay, so if an electron is at excited state, it is not a stable state. Now, if it is not a stable state, it means electron is an unstable right now. And all the atoms want to be stable students. So what will happen? That electron will finally lose its energy and come back to its own orbit again. So what will happen here? Here it absorbs the energy, student. Here it absorbs the energy, due to which it jumps to the next shell, and this state is known as the excited state. An excited state is an unstable condition. It is unstable, electron remain unstable at excited state. So what will it will do? It will lose the energy. It will lose the energy and finally it jumps to the same energy level. Okay, so at first it absorbs the energy, jump to the next energy shell, become excited state. And excited state is an unstable state, so it will lose energy, and finally as it loses the energy, it will go back to its own state. So you see here, students, that as before that it was E2. This E2 was what, student? Let me explain to you again. This one even, at the first one it was even, it absorbs the energy, becomes E2. So it jumped to the next energy shell. Now this energy shell is what? It is a unstable condition. Okay, so what it will do? It will lose the energy again. Okay, so as it will lose the energy, student, then what will happen? It loses the energy, so again it will become even. So finally, after losing the electron, after losing the energy, the electron comes back to its original, or we can say energy level or shell. Okay, so why is it so? It is because as it jumps to higher energy level, the state is excited state. So when it absorbs the energy, it jumps to the higher energy level, and finally it loses electron and jump to the lower energy level. Okay, so before that, student, you know that it used to rotate in its own orbit without losing or gaining of the electron. But when an external source of energy is supplied to it, it will absorb the energy and finally jump into the higher energy level. But that state is an excited state. That state is an unstable state, so it will again lose energy and finally jump back to the lower energy level. Okay, so as it absorbs energy, it will goes to the higher energy level. As it releases energy, it will goes to the lower energy level.